So what I just told you explains the distribution of nutrients and oxygen in the open ocean. Okay, and there are two sketches. Okay, and the vertical distributions on the left side compares the nitrate nitrogen distribution in the Pacific with that distribution that you find in the North Atlantic and the South Atlantic Ocean. On the right hand side you see the dissolved oxygen distributions. Okay, and this is something that we discussed before. Okay, so if you move through the deep oceans and you look at nutrient concentrations, you can see an increase from the North Atlantic through to the North Pacific, and this is because of the deep circulation picks up detritus as it moves along. Okay. On the other hand, you can see this also reflected in the oxygen distributions. Okay, look at the right hand side in the North Atlantic. Okay, so just south of Greenland. In this profile, you can see the oxygen is all above the minimum. Okay, so what the unit is milliliters per liter here, and the critical level that you need is something like 1.4. Okay, so in the Greenland Sea, south of the Greenland Sea, enough oxygen, no limitation whatsoever. Okay, and this is to do with the open ocean deep convection. Okay, which ventilates the ocean. Plus, you have cold water. Okay, has a high solubility of oxygen. Okay, South Atlantic, you already get you get a signature, you get a little minimum or so. But have a look in the Pacific. Okay, Pacific, you have a zone where there's not enough oxygen to support marine life. This is a dead zone, and it's a natural dead zone because this is just not reached by oceanic currents. Okay, it's relatively high levels of whatever. If there's something, it's a high level of oxygen demand by bacteria, plus no ventilation in this area, or very little ventilation. Okay, so you learned about the oxygen and nutrient distributions in the ocean. Indeed, oxygen's distributions are critical for marine life. Okay.